Now I'm on. Hello, welcome to Friday Night Livestream from Kopernik Observatory. My name is Drew Desker. Glad to have you here with us this evening. Just want to say that we really appreciate all the people who have subscribed and started, have been engaging with us as best as we can remotely. We've been having a lot of fun doing it. We've certainly been learning a lot about doing live stream, and so we appreciate your patience with us. We'll have our program here that'll start on Perseverance, the next rover from NASA that'll be starting fairly soon. And then also later this evening, we'll be doing another live stream of the comet Neowise and possibly even the moon, even at as early as 9:30. So keep an eye on the live stream, and after this program around 9:30, see if we'll be back. But our plan is to the skies are supposed to be pretty clear tonight, and so we'll try to shoot the moon. We'll try to capture a bit of the comet and maybe do a bit of a star survey or a planet survey in this case. Just to make you aware, we've been doing we've been having a great time with our summer camps. We already have 4 of them over. We have another 4 to go. Next week is actually, that camp is actually full. The week after that will be a camp on sort of virtual reality for middle school students. We'll be doing a backyard biology camp the week after that, and then the week after that is our Welcome Aboard the ISS, where the students are going to learn about what it takes to become an astronaut, what kind of training they go through, and we actually will have an opportunity to have our students talk directly to an astronaut on the International Space Station using the ham radio station we have here, connecting directly to the ham radio station that's aboard the ISS. So we're going to have a lot of fun with that.
Still room.
There's still room in all but next week's camp. So go out to our website and you can learn more about it and get registered. Again, one of the other things also here is, as you can imagine, normally you would be here, and unless you remember, you'd be paying to get in. We're not paying to make you watch this YouTube channel, but down below in the description, there's an opportunity for you to support us. So if you're in a position to do so, any amount will certainly be helpful and appreciated. So at this point, we are going to now move. We're going to pan the camera over to Tish Bresee, who will get our program started. So over to you, Tish.
Okay. Hi, everybody. This is Tish. I'm your solar system ambassador from NASA and the Jet Propulsion Lab. They send me material and I share it with you. So we have a chance to learn a lot in the next half hour to an hour. And then don't forget to stay on this channel for more viewing in the evening. So have you been looking at pictures of Mars? Well, I'm surrounded by pictures of Mars, and I brought some of Mars with me. So I'm going to put my gloves on, and so I can show you some Mars. And as soon as Drew shows me my first page,
Okay, so we're going to switch to the program.
we're going to see what that looks like.
And we will go to...
Don't be, I want to see this page though.
Yep.
Okay.
You want to see which page?
I want to see me
Oh.
doing this.
Okay, well then we need to stay on you.
Okay, let's stay on me then.
All right.
Here's a sample of Martian dirt and a sample of Martian soil.
Actually, what I'm going to do is I'm going to bring the camera over to you a bit.
A little bit closer. Okay, here's my astronaut.
Hold on a second.
The first person on the moon is not going to be a man, it's going to be a woman. But the first person on Mars can be anybody. And here he goes, or she goes, into the Martian soil. All right, now, what happens if a little bit of water gets in here? Let's see. Take a guess. Is it going to blow up in my face? So the Martian atmosphere is carbon dioxide, and this gas stays along the ground. Look how it goes down the table and bubbles and boils. The carbon dioxide gas is all over on Mars, and when water hits it, it evaporates so quickly it turns into a cloud. Here's my astronaut in the Martian soil, 109 below zero here in this container. So if you were trying to experience something like this, it'd be radiation you have to deal with, and meteorites, and all kinds of dangers on Mars. Maybe you would like to have a challenge like that. Well, we're going to teach you how you can overcome some problems going to Mars. Here we go. Okay, we're going to switch over to pictures. Let's see what NASA wants to share with us this evening. We have some surprises in here too, so take down notes. And Drew tells me that this presentation will be available to you on the Kopernik.org website, so you can get the links that are provided by NASA. Let's keep an eye on this. This is me. I'm your solar system ambassador, and this is the space station and the new rockets that are being built right now down in Florida. They're being assembled, and can't wait to see who's going to launch next after the Rover, which is, I'll show you that in just a minute. This is a pre-launch briefing, which means the launch is coming up soon. Let's see.
Is it click work?
Let's go. This is music from the Martian called Making Water, and you might remember that it involves a little bit of hydrogen and experiments with that. That was pretty exciting. That was one of the first problems that he had to solve. Let's go on. And I'm going forward. So imagine that you are getting ready to land on Mars, and the whole world is watching you. Will you have problems to deal with? Could you solve those problems? The whole world has had a hand in your job, and your job is to survive on the planet. He said it's a beautiful morning on Mars.
Today is much more than a new chapter for mankind.
Oh, gosh. Now there's a problem, okay? The first thing you have to do is get up, all right? So I want to thank Dr. Ryan McDonald for this little commercial that he found all about Mars, and a little funny spot there. So what do you say we get started on the reality? All right. So what do you know about Mars? Well, let's take a look at this up-close picture from the Hubble Space Telescope. Can you recognize any features? Well, it's definitely a globe of desert sand, okay? This it's kind of orange-colored sand, cinnamon-colored sand, tells us that it has iron in it, right? Okay, so it's very dry. We don't see any running water, except we see evidence of water, like maybe here.
Nope.
Valles Marineris, there's a great big crack. That's great, thank you, Drew, that's terrific. And on the left side of this picture, some giant volcanoes, at least 4 volcanoes, that could maybe solve your problem of trying to beat the cold. All right, here are some of the problems you might come across. Let's see. How far away is it? Well, it's about 6 months ride at least, so you're going to be prepared for that. 1/3 the gravity, so that a lot of people might think that's a terrific idea. I'm going to weigh 1/3 of what I weigh here on Earth. Gee, I can jump 3 times higher, so terrific. But that might be a problem with your equipment. Let's find out what else. What about the air? It's 1/100th of the Earth's air pressure. So the pressure outside our body, right here on Earth, is balanced with the pressure inside our bodies, and it's comfortable most of the time. Maybe you can actually feel a storm coming along when there's a low pressure system approaching. But on Mars, 1/100th of the air pressure means it would kill you. All the soft places like your eardrums and your eyeballs would go first. And that's something you really need. Okay. Let's see, what else about the air? It's cold. Now, it is possible that you could find a spot that's about 50 degrees plus Fahrenheit, but that's only occasionally, and it's way down around your ankles, somewhere along the equator area. But the average temperature is really cold, below 100 degrees Fahrenheit. So we have to find a way to warm up. And one more thing, the atmosphere is carbon dioxide. What do we breathe here on Earth? What are we used to? Well, everybody seems to say, what? Oxygen, right? It's true, oxygen is in there, but that's not most of the air we breathe. Who knows the N-word? Everybody thinking of it? Yeah, nitrogen's the one that we need to bring with us. Okay, so there's a lot of things that we have to overcome when we go to that planet. So are you pretty good at reading maps? Let's see what's on the planet right now. Let's look at this beautiful MOLA map. It stands for Mars Orbiter Laser Altimeter. That means it's an altitude map. And so if you look at the bottom left, you'll see the elevation in kilometers. The white is the highest mountain, and you can see the 4 volcanoes in a row, Tres Montes and Olympus Mons. They are the highest places. There's a couple of other spots that are very high. That's going to be tough for our rovers to climb, so we want to stay away from those. And the lowest places, let's see, which ones are the lowest? What color? Purple. Okay, the violet colored places are going to be the lowest, and that's Hellas Basin, and you don't want to go near there with your rover either. Please don't walk in there because the dust is really deep and you'll sink down in, and you may not be able to get out if you're a rover especially. But maybe the helicopter Ingenuity could figure out a way to get in there. I don't know. All right, so the medium areas are yellow and red and green. And we're looking at a place called Jezero Crater. Can you find Jezero Crater? I'll give you a hint. It has a red dot by it. I think Drew found it. Jezero Crater is at the edge of a cliff where there is water flowing into a beautiful delta. And we'll take a close look at that later. But that's where we hope to land the Perseverance Mars 2020. Notice that Oxia Planum is also listed as a place for landing. This would be the ExoMars. It was going to leave this year, but they decided in Europe that it wasn't ready to go yet. So they're going to have to wait 2 years and 2 months for Mars to come around again. So Oxia Planum will have to wait. While we're here, let's see if we can find the other rovers, like, see this really big picture? Can they see this?
I should be able to,
Maybe.
actually.
I've got a flashlight in my
Actually,
hand.
here.
Oh, it's flashing. Okay.
There you go. Yeah, now actually, take the flashlight out, I can see it.
A spotlight on the older rovers, the twin rovers. This is Spirit and Opportunity. Can you find Spirit and Opportunity? Oh, thank you, Drew. Spirit and Opportunity are twins, and they lasted a really long time, 2003 to just a few years ago. So they lasted much longer than we ever expected. Can you find Opportunity and Spirit? All right. We can turn the lights off now. All right. Can you find Curiosity? Curiosity looks a little bit like the twin rover Spirit and Opportunity, but it's bigger and stronger and a lot more equipment. Curiosity on the right is not too far from Insight. Insight is a geology tool meant to measure not just the weather, but the earthquakes, or sorry, Marsquakes on the planet. All right, so those are, and I didn't mention the Viking 1 and 2. Those are the most ancient ones I know of. And the Phoenix up on the top left, which is now covered with snow, but I suppose you could dig it out if you want to go up there and find it. The Phoenix doesn't have wheels. It's stuck there, and so is Viking and Viking 2. They're not going anywhere. And Pathfinder is a rover about the size of this sign. And Pathfinder is stuck as well. All right, so Spirit and Opportunity are going to stay where they are because they were purposely shut down. They were unable to move for quite a long time, and then they got cold and ran out of energy. After a while, the solar panels got so dusty that they couldn't revive themselves. But hey, I'm going to show you why Curiosity and Perseverance are especially nice in that area of power. Let's go farther. When we go out into space, where do we have to launch, and how long will it take? Can you find Earth? Earth is the third planet from the sun, yeah? Okay, so the orbit of the Earth goes around to the right, and then we'll catch up with Mars, and eventually the launch from Earth to Mars will catch up by, like it says, transfer orbit from Earth's orbit to Mars injection in about 6 months. And I told kids, I've been teaching a long time, but at first we thought 8 months was the best we could do, but right now they're saying 6 months is going to make it. So Perseverance should make it there by February, which is 6 months, and that's pretty fast considering it's, you know, millions of miles. Okay, I'll bet you could grow up to be an engineer though, and possibly go faster than that. Wouldn't you like to go faster? Yeah, me too. Okay, so maybe we could even go to Venus or Mercury, huh? Jupiter? All right, so let's take a look at the Perseverance rover. If you look carefully, you can see that each one of these tools is either a camera or a spectrometer or a weather station. Weather station probably won't show up, will it? No?
Nope.
Okay. Let's start over here on the right. Sherlock is an ultraviolet spectrometer. Its job is to look at the ground mostly and look for details that only an ultraviolet spectrometer would pick up. Ultraviolet loves to find things, especially ice, that are white. Notice Pixel is on the same arm. That's an X-ray spectrometer, and that's looking for things that are radioactive and probably very, very old, like the fossils we might possibly pick up. Notice the Moxie in the center. Its job is to turn carbon dioxide into oxygen and carbon, and to get the carbon out of CO2 is not easy. So the person that invented that is really brilliant. If we could get a really big Moxie, we could probably make enough oxygen to help people out who might want to live there. Notice RIMFAX is a radar looking down through the ground. So maybe it will be able to tell if there's ice or water down below the ground. The MassCam is a camera for looking all around, and the SuperCam is a laser micro imager, so that's for looking really far away in all directions. The head is about as tall as a big person, adult, and so its eyes have been programmed to be about the height of a human's eyes. There's a lot more to it though, so let's move on to the next part. I would like to thank the nice people at the Jet Propulsion Lab who sent us these images and these little 3D images. What we have here on the left is Perseverance being packed into its heat shield on the left. The gold bottom part is the heat shield, and in the center you can see the nose cone, what's the other name for the nose cone?
Fairing.
The fairing, thank you. And it's padded on the inside, and so it's gonna squeeze in and then close on the right. You'll see it's all closed up, and it's on the nose cone of the Atlas rocket right now. I want to talk to you a little bit about the launch a little bit later, because it's very interesting that it's not going from Cape Canaveral. I'll show you what I mean. So thanks a lot, Sarah Marcotte. She's been very helpful to Kopernik, and when you want to learn more about Mars, she's going to help you a lot. When you come to Kopernik someday and you take classes, especially the ones about Mars, she's going to send us a lot more equipment and stickers and fun things like that. So Sarah gave us this launch window page. We think it's going to be July 30th at 7:50 in the morning Eastern Time, but we're not sure. So follow this launch chart, and you will be able to see that if it's the next day, it's a little bit later, and it keeps getting later. But it's pretty much in the morning each day, and we hope to get it launched by the 17th, which would be nice. Sorry, by the 17th day, which is August 15th. Aren't we doing ISS at that time?
That's,
Yeah.
we could be, yeah,
We have
that's
a
the
really
week.
cool class coming up that week.
Actually, it starts on the 17th and goes to the 21st.
Yeah, well, it's August 15th then. Okay, well, we'll see how long it takes. I know that sometimes the weather isn't perfect. We'll have to watch. The good thing is they won't let us down there, but it's also a bad thing. I guess you can't get really close. But you can watch it every single day from nasa.gov, NASA TV. I can see it on my YouTube or NASA TV on the Roku system, so you can see it that way too. Okay, so mark that on your calendar, July 30th at 7:50 in the morning. We're going to be here. We're going to talk about it. We're going to follow it right here. Here's the rocket. This is the Atlas. Atlas 541. It's not huge, but it has boosters, and it has enough to get that whole big fairing up there into Mars area. So how do you watch? NASA TV, nasa.gov live, youtube.com, NASA's channel. You can also see it on Kopernik's channel, isn't that correct? Mm-hmm. Okay. Let me make sure I got it. Oh, what I wanted to tell you that was interesting was it's going to be at the Cape Canaveral Air Force Station. Now, I've been there before, and it is huge. I mean, it's right next door to the Kennedy Space Center, but Kennedy Space Center is closed, and they're also working on the launch area for Kennedy. So that whole area is fenced off. You can't go in there. But where the Air Force Station is, there's a couple of launch areas, and this is a special launch area 41. The launch complex is all set to go. I saw something land there. It went right over the highway and right over my car. It was very exciting. You gotta see the launch on that, maybe online, okay? It's gonna be cool. So NASA would also like you to know that you can order these, and you can also get a PDF of a virtual launch packet. It has all the information you want. So if you go to nasa.gov, and it's mars.nasa.gov, you will be able to order one of these packets, or you could just use the PDF version. I'd like to show you what it looks like when you're examining the ins and outs of all the parts. Let's take a look. If you click on one of these, loading the 3D model, you'll be able to see the parts, and when you click on them, you can choose a part, move it around. It will tell you the function of that. for example, I'd like to see the power in the back. Notice there's no solar panel. That tail that sticks up in the air looks like a bug's tail. That is containing a fuel rod about this long made of plutonium. And it's meant to last for years. And it can even have the rover working at night. Curiosity has one, and she's doing pretty well. Let's see, she landed in 2012.
Mm-hmm.
She's still going, and it's 8 years later. They do shut her down occasionally, but they keep her warm when it's so very freezing, 150 below zero. So this is a terrific thing, having a nuclear power pack. Let's see the front, if you could please go around the front. And we're going to get a close look in just a minute of the drill business, but on the right is the drill arm right there. A little bit closer. There you go. And if you can whip that around, we can see the drills. I'll let you guys play with this, because once you get it, you can play with it all you like. And you can see there are different tools here.
Yep.
Some of them are cameras and some of them are drills. And what they do is they turn the rock into powder, and they save it in a little container. And they save that container, and it's going to go back to Earth on the next mission. The plan is to send another mission in 2 years and about 2 months. And I believe it's going to take that same soil sample, several of them I believe, back to Earth with a special rocket. They'll send it up to an orbiter going around Mars, and then that's going to send it back to Earth. So we should be able to get that soil sample with maybe, wouldn't it be exciting if it had a little bug in it or something, or a fossil, or even it's just a piece of an amino acid, a sign of life of some kind. We're pretty excited about that. It's going to take 4.5 years, so be patient. So these core samples will be saved and taken back to Earth. Okay, let's go to the next page, and I think I can get us there.
Yeah, you want to go back to the PowerPoint?
Yeah, please.
Good.
There we go. All right. I want you to notice that on this page, they have been so careful about putting in little details, like, look on the right side, explore as one is written in Morse code in the metal plaque here on the front of the rover. And it says that there's more to it than just that. You're going to have to read the article, because I know there's more to it than just the Morse code. Anyway, there's a lot of symbols there. On the left side, just details, just like you would do on Twitter. You'll be following on Twitter, and she will respond back to you. Perseverance will actually, have one of the rover drivers respond back to you from Twitter. Give that a try. Okay, I'm going to move that ahead. There we go. Okay, these are the different animations that you can order for yourself. I would like to try one of these myself, and Drew, could you please click on Building NASA's Mars Rover number 2?
Number 2.
I think it'll work. that's a fast version of how they build it, and I think we'll just, thank you very much. So
sorry.
there's several of these. We're gonna move ahead though to the passenger on the Perseverance. Why don't we go ahead?
Also, we will, in our description, we will give you links that you can click on when you come back to this video, where you can actually go to each one of these hot links.
Yeah, we would like you to enjoy them all, yes. Okay, I'm gonna go ahead to the site where you can learn about the passenger on Perseverance, and this little guy is hilarious. Ingenuity,
Wait, click here.
yes. Ingenuity is a helicopter, but it's more than just that. Imagine 1/100th of the air has to fly, so how would you possibly have enough push to go up in the air? Well, that took quite a lot of work to figure out the propellers on this guy. Now, if it's possible, I'd like to go down to 5 things. 5 things to know about Ingenuity, the flying helicopter. First test of powered flight on another planet. It's built to be light and strong. Weighs less than 4 pounds. Powerful enough to lift off the thin Mars atmosphere. The helicopter may fly about 90 seconds, and then it has to recharge itself. Goes about 10 to 15 feet from the ground. And the helicopter flies on its own without human control. So most of it is pre-programmed. I think if we go down again, you'll see it being born. There it goes. The debris shield drops off underneath the rover. The vehicle, yeah, it releases, and then it has to become upright. A couple of moves there. Notice there are 2 blades. There you go. Then it unlocks the legs, 4 legs. Very lightweight material. And it drops it. And then it shows you again. So the debris shield comes off, and it rights itself, and the legs come down, and then the mama goes out and does her thing, and I'd like you to see what it does. Let's see. I think we've got to go back.
Go back to the...
Yeah. Okay. Taking flight on another world. She lands, and then the mother comes over and picks it up again, just like being born again and letting go. It's so funny to watch. I was hoping to show that to you. Maybe if I go back one. Let's try the full animation. Okay, we're going to just experiment a little bit, guys. Hang on. Yeah, that's the one. Okay, so you can't see the helicopter, right? This is Perseverance. There it is. Okay, it didn't show it coming out. So it's already dropped down. Now it's going to start up. Notice in that box it's got a camera and a battery. There's a solar panel on top, a really small one. There it is. Starting up. Waiting for Mama to say go. Perseverance is going to watch the whole thing. Watch her eyes. This is animation, not real. Sounds just like a drum. Yeah. that's what we expect it to do. So it could be useful for looking around the area because it can go up about 15 feet. There's Perseverance watching. That's cool. I imagine it'll take a few days before they'll get it running, but when it finally does come out, we'll follow it. And the pictures. Okay, that's good. So we can get out of the multimedia. I'm going to wrap up with some interesting facts about the way we're going to go ahead in the future. We would like to thank Alan Chen from the Jet Propulsion Lab for his ideas on Perseverance and how the entry, descent, and landing system is so unusual. What they're trying to do is make it easier for it to actually land in the correct place. Let's see what happens. From the outside, Mars 2020's entry, descent, and landing looks a lot like Curiosity's, but they've added some major new landing capabilities like this. Here is the ellipse for the four rovers. The Pathfinder's is 200 kilometers on the bottom. The Phoenix and Insight had a 130 kilometer ellipse. So that's a large landing area. And then Mars Science Lab, the Curiosity, had a 25 kilometer ellipse. And now Mars 2020 Perseverance can narrow it down to 7.7 kilometers wide. And that's a good thing. And this is how it does it. It has a special new landing technique called the terrain relative navigation. It takes pictures of the area it looks like it's landing on, and it can adjust and divert if necessary. Let's see how that works. This is the target. It's Jezero Crater. You see the beautiful delta where the water gushed the mud in and dried up eventually. Maybe we'll get lucky there and find some fossils. This is the same terrain relative navigation here on Earth. This helicopter has nobody in it, but it does have the camera for the TRN. Anybody's been watching and Martin, you want to make a comment about that? I'd love to know if it was from here.
Hold on, sorry. John, it's a little loud, so I was just trying to turn it down.
Oh,
Sorry.
okay.
Go ahead. Oh, now we're starting over again. I guess we were over again.
Well, we just, I'm not sure whose helicopter that is, but the equipment for landing is the TRN, the Terrain Relative Navigation. So it helps it find a place to land. Now we're going to see what that looks like. All right, I'm going to go to this one. This is what it looks like up close. It's a little picture of Elvis on there. I don't know why, but we'll find out somehow. A multi-camera system that's constantly looking at the terrain and choosing where to land. This is in Death Valley, according to Alan Chen. A little bit like Mars, I guess. Have you ever been to Death Valley? Anybody? No?
No.
So that's how it works. Helps it to land. And I hope that it will get more of a successful landing. You know, 3/4 of the rovers, landers I should say, have crashed over the last 50 years. And we're doing a lot better now. We'd like to have 100% make it. Okay. We'd like to also thank Dr. Ryan McDonald, who was here. He was our last speaker before the COVID virus struck here on February 22nd. We had a really nice Winter Star Party, and he said that I could use some of his pictures because they're so exciting. I want you kids especially to think about how you could maybe be one of those passengers on this giant spacecraft going to Mars. Or maybe one of the NASA spacecraft. Or from Boeing. We notice that SpaceX likes to land this way, vertically, and they've proven it to work. And this is animation. There we go. And some ideas for where you might live. If we could get robots to produce habitats in large quantities and storage areas, then we would have it already set up for you when you get there. This is one idea. If you're a pretty good artist, you might want to be one of those people that designs the habitats in the spacecraft. Let's take a look at another one. Maybe a giant greenhouse is more like what you'd like to see on your habitat. Already the Europeans and the Japanese and the Chinese have a robot that they're building for the moon that scoops up soil, and it's a little bit like this. It's meant to produce 3D printing habitats. So a whole truck full of these little robots come out. They have solar energy, and each one has the ability to replace another. And after they scoop up the soil, they can melt it down and use it to build things. I like this part. Melt it down. Yeah, okay. All right. Might work. All right, I'm sure you're thinking about what you would do if you were going to be living on Mars. You know, you'd have to stay there about 3.5 years, maybe 4, because we have to wait until the Earth comes around to next to the planet. So think about that. It's a long-term deal. A little help from Curiosity to remind us about the job of the rovers. This is Curiosity's selfie. She took this last summer. Boy, was she getting dirty. Look closely at the wheels and you'll see how they're decomposing a bit. This was Spirit and Opportunity, that one right there. This is Curiosity. If you want to know how she took a selfie without showing her arm, you'll have to come up here and learn it from us.
There's the wheels.
So Curiosity's big brother is coming, and it's going to be Perseverance. And I think that's it, except for the questions, yeah? So if you have some questions that we can answer now, we can help you out.
All right.
Thank you.
one of the questions asked is, do you have any animation of the landing process for this? I think it's going to be similar to the sky crane for Curiosity.
Yes.
But they don't have an animation like they did for Curiosity, do they?
It's not a bundle that I've seen,
Okay.
but like I said before, the first part is the same, but that special camera that helps it find its target is new.
All right. Let's see here. I guess we'll hang a little bit longer, and I don't know if there's any other questions that people have.
Okay.
And but we hope to be able to live stream the launch with some additional commentary. So our first opportunity, a little Mars Rover joke there, will actually be this Thursday, July 30th, and so watch for the live stream popping up, on your email, saying that we've gone live, and we'll have a little commentary and be using the special NASA live stream that we've been granted access to. Again, for those that arrived maybe a little bit later, again, well, first of all, we thank you for joining us this evening, and if you're in a position to help donate to our cause, there's a donation link right down below that you can donate securely. Another thing also I'll tell you about is that Kopernik is now actually in a little voting contest this coming week, and if you go to our website and if you're on our email list, we'll tell you about it. Starting Sunday at noon, there's a company called Upstate Shredding that has been giving $2,000 a month, a week, to various nonprofits in the area, and Kopernik is one of the ones selected for August. And so you'll be able to vote once a day for 5 days, and if we are a top vote getter, then we will be the recipient of a $2,000 grant from the Upstate Shredding, the Southern Tier Tuesday Foundation. So, all right, at this point, I think I don't see any additional questions. So, did you have a video you want?
I think we're all set.
I think, all right. Well,
Thank you.
okay, so I'm going to switch back to me here for a second. So we'll go back to a webcam, and so thanks again for joining us. Again, check in another hour or so. Jeremy will be setting up his cameras and live stream equipment out in our telescope domes, and we will hopefully be able to grab the moon before it finally sets this evening, and then we'll stick around looking at not only the comet, but also Saturn and Jupiter are going to be up, and who knows what else we can find. I looked there. Unfortunately, the ISS is not going to be visible this evening to us. It's moved later and later, so that now it's going to be more of a week or two before we'll start seeing it more in the early morning. And but anyway, so I thank you very much for joining us here. Oh, hold on here. One person did ask, does Curiosity have any kinetic energy braking? I don't believe that they would be using that because they don't really have a battery storage system per se.
The rocker bogie system helps it move, but I don't know anything.
I don't know
about
that
brakes.
it's officially like a kinetic energy braking.
I don't know.
Yep, we're unaware of that. So.
We will find out, though.
All right. Well, thanks again for joining us, and hopefully we'll see you in about an hour's time